morning, students. Welcome to our lesson for today, secondary mathematics. Today we are looking at Form 2 work, and we are focusing on the topic linear inequalities. So welcome, and I hope you will enjoy the lesson. In linear inequalities, we need to understand a few things, but before that, we draw the foundation of this from Form 1 topic called linear motion. And by now we are all conversant with linear equation, which is taught in Form 1, that gives the foundation of what is a linear equation. And now when you come to linear inequalities, we simply do something small to linear equations to make them inequalities. And what we do is what we call, we substitute the equal sign with what we call the inequality signs or symbols. So what we mean is, when you're talking about a linear equation, they are of the form y is equals to mx plus c. That is a linear equation. And we say they are linear because the highest power of x is 1. That is why we call them linear. And when talking about linear inequalities, now what we do is we replace the equation or the equal sign with what we call the inequality signs or symbols. We replace the inequalities, the equal sign with the inequality signs or symbols. And so what are these symbols? That is the inequality symbols or signs. These symbols or signs are 4 in nature. We have this first sign. It appears like a V, an inverted V facing to the right side. It denotes or simply means greater than. So when you have this case, this is greater. And the opposite now facing to the left side, we refer to it as less than. So this becomes less than. Those are the two main inequality signs. Now we do something good to these two to form the other two. When you have greater and a line below it, then this one, what it means is greater than or equal to. Greater than or equal to. Equal, you can write the same for less than and have this. This one, it will mean less than or equal to. Those are the 4 inequality signs that are going to be substituted in this case. Where there is an equal sign, we will now replace it with this inequality sign, and then we form what we call linear inequalities. Again, linear because the highest power is 1. If the highest power is 2, for the Form 2s, they will understand that will become a quadratic equation. But now we are looking at cases where the highest power is 1, and we replace them with the inequality symbols to obtain what we call linear inequalities. And so those are the things that we want to concentrate on in our lesson today in analyzing 3 main areas. The first thing that I want us to be able to analyze is what we call solution of simple linear inequalities. Solution of simple linear inequalities. Simple linear inequalities are the same as what you looked at in Form 1 under linear equation. You looked at solution of linear equation in one unknown. And for example, just to remind you, if we had this case, you are told to solve for x. Solve for x in, then you have 2x less 1 is equals to 5. That is a linear equation. This is what we are calling a linear equation, but a linear equation in one unknown. Solution to this, what happens is we have 2x less 1 equal to 5. We collect like terms. We collect like terms. In this case, we take the negative 1 to the right-hand side. So it becomes positive. And then we have 2x equal to 6. So how do you get x? If 2x is equals to 6, then to get x, what you do, we divide both sides by 2. We divide both sides by 2, so this cancel out, and x becomes 3. That is a solution. And so this is what we are calling solution of linear equations, which is in one unknown. The same concept is what we want to bring in the solution of simple linear inequalities. So the same question now can now appear as follows. If we have this case, you're told now solve for x in, then you have 2x less 1 greater than 5. Same case, but now instead of equal sign, we've replaced it with one of the inequalities that we have here, which is greater than. So how do you solve it in this case? Solution of linear inequalities is the same as solutions of linear equations. And so the same procedure that we do when we are solving linear equations is what we do in the solutions of linear inequalities. But remember, students, do not at any point replace the inequality sign with an equal sign. In the interpretation and analysis of it, in our mind, we hold in an equal sign, but do not replace it here, because once you replace it in this case, you now change the equation from being an inequality to an equation, and that becomes a different question from the one you've been asked. So what you do here is simple. Again, 2x less 1 greater than 5, simply collect like terms. So we'll take negative 1 to the right side. So we have 2x greater than 6. Then what do? We again divide both sides by 2. So if we divide by 2, this divide by 2, this cancel out, x becomes greater than 3. So these are two cases. One, there is a solution here for x equal to 3. And there is a solution here for x greater than 3. The interpretation is quite simple. That in this case, x is exactly equal to 3. There is no any other value for x apart from 3. But now when dealing with inequalities, when you have x greater than 3, then we've been able to give out a wide range of values for x. That we are saying x is not only 3, but all the numbers that are greater than 3. So it could be 4, it could be 5, it could be 6, it could be 7, all the way to a known number of values n. Why? Because x has to give us the values that are greater than 3. That is the difference between the solutions in inequalities and the solutions in linear equations. We can have another one. If we have this as our example 3, you are told to solve for x in, then we have 3 plus 2x less than or equal to negative 3. Now, what we've only done here is we've started with 3 instead of 2. Because students will always think that the equation has to start with x. It can start with any number as long as the arrangement is based on this inequalities or inequality symbols, then it becomes a linear inequality. But now the difference between this and this is that you'll see what will happen. If we solve this, 3 plus 2x less than or equal to negative 3, you take 3 to the right side, that becomes positive. So 2x less than or equal to 0. And so in this case, when you divide by 2, x becomes less than or equal to 0. If you look at the number line, this is 0, negative 1, negative 2, negative 3, and then this is 1, this is 2, this is 3, this is 4. The values of x in this case, at x is equals to 0, the values of x which are less than 0 are defined by all the values of x to the left of 0. So that is how we can represent again this solution, that x is not only equal to 0, but all the values that are less than 0. And that is what the inequality number 3 will mean. So these are what we call simple linear inequalities, connected to what we call solutions of linear equations with one unknown in form 1. Good. Number 2, we want to bring out now what we call compound linear inequalities. So that is now our case 2, solution of compound linear inequalities. Solution of compound linear inequalities. So what are these compound linear inequalities, and what is the difference between simple and compound linear inequalities? If we have a definition of two values of x, so if x is greater than 2, if x is greater than 2, and again x is greater, that is less than, greater than 2, but less than or equal to negative 3. Then these two values of x can be combined. We can have a combined solution of x. And for students to understand how we combine, first you need to understand between the two given values of x, which one is smaller and which one is greater. So this is the easiest way to combine them. Negative 3 is the smallest value of x, and 2 is the greatest value of x. These two solutions are solutions for x. And we are saying that x is greater than 2. So we replace it here. But now, on this other side, x is less than or equal to negative 3. So if we start with 3 now, then we'll say negative 3 should be greater than or equal to negative 3. So this becomes a combined solution. And so this is now what will now constitute to what we call compound linear inequalities, where we now bring two more than one inequality sign in one equation. And so I want us to use this example to illustrate basically what we mean. Solve for x in the following simultaneous linear inequalities. So we have 2x plus 3 less than or equal to 5. And then another inequality is x plus 1 greater than or equal to 2. These are two inequalities. They are forming what we call the simultaneous linear equalities that we need to solve and determine the values of x. Now, solve each one of them separately. If we start with the first one, if we start with the first inequality, where we have 2x plus 3 less than or equal to 5, the procedure that we followed at this stage here will be followed at the same case. We collect like terms. This to the right side becomes minus. And so we have 2x less than or equal to 5 minus 3, that is 2. And therefore, divided by 2, x becomes less than or equal to 1. On the other side, we have x plus 1 greater than or equal to 2. We'll take 1 to the right side, becomes negative. So x greater than or equal to 1. So those are the solutions of x. That x is 1 less than or equal to 1, and again it is greater or equal to 1. Now, the same case can happen for this one. Now, you're told to solve for x in, then we have 3 plus 6x greater or equal to 3x plus 1 less than 5. We've combined now, instead of writing them separately, as it in this case, now we have a combined inequality, bringing two inequalities together. Students need to know how do you obtain simple inequalities from compound inequalities of this kind. Because in our case, the first thing is you obtain simple linear inequalities. And how do you do that? First, you start from the beginning and go up to where the second inequality starts. The second inequality starts at this point. So you extract that as our first inequality. 3 plus 6x greater than or equal to 3x plus 1. Number 2, now start from the last up to again where the second inequality from that side begins. So that is at this point. And so we have 3x plus 1 less than 5. And solve these two linear inequalities. Solve these two linear inequalities. So when you solve one, we have 3 plus 6x greater than or equal to 3x plus 1. We'll again collect like terms. So let's see our like terms. This is 3x to this side, and then 3 to the right hand side. So it will be 6x minus 3x, which is 3x, greater than or equal to, we have 1 minus 3, that gives us negative 2. Then we divide this by 3, and this cancel out, so our x is greater than or equal to negative 2 over 3. We solve now number 2, solving 2. 2 has 3x plus 1 less than 5. The same thing, collect like terms, this to the right side, and so you have 3x less than 4 over 3, this cancel, and so x is less than 4 over 3, that is 1 1/3. If we combine these solutions, then we can have a combined solution of this kind. Between -2/3 and 1/3, which one is greater and which one is less than the other? You realize -2/3 is the smallest, so we write -2/3. And the largest is 1/3, so 1/3. And they are all solutions of x. So what you do, we are saying that x is greater or equal to -2/3. Then it means if we start to -2/3, then it will be less than or equal to x. And then you replace in the other one, automatically it becomes less than 1 and 1/3. That is a combined solution from this example 2. But what I want you to understand is how do you obtain simple inequalities from a compound inequality of this kind, where there is only one statement but constituting more than one linear inequalities. Then once we've done the solution of both simple and compound linear inequalities, number 3, I want us to know how do we obtain linear inequalities from a given region. Because you find most of the time, we'll shade for you, give you a shaded region and ask you to determine the inequalities. That is now determining linear inequalities. Linear inequalities defining a given region. Defining a given region. In this part, the examiner will draw for you a region and then ask you to determine the linear inequalities. What you only need to know here is that the only thing you'll be doing is you will have to find linear equations. Linear equations defining the given lines. And then you replace the equal sign with the appropriate inequality. That is what we will do. That yes, we shall have a region that is shaded, but from there we have to look at the equations of linear straight lines. Those equations now, we use them to explain the given inequalities. For example, you are told to write down the inequalities that defines the region R below. So you have this kind of a drawing. This is the y-axis, this is the x-axis. This is 1, this is 2. So you have this line. This is -2, this is 0. This is 4. So you've this kind of, and this is the region R. And so you are asked to give the inequalities that are defining this region R. We shall follow this NB. That we have to, for each of the lines that are enclosing that region, get the inequalities or the linear equations first, then we shall replace in with the appropriate inequality sign to define the given region. So how do you solve this? How do you solve this? Simple. Let's mark this as line A, this as line B, and then this as line C. From the three lines, there is one simple line, which is line C. Line C is the x-axis. So we start from there. That line C, being the x-axis, what is the equation of the x-axis? Yes, the equation of the x-axis is y is equals to 0. That is the equation. But if it's the y-axis, it becomes x is equals to 0. So for these values of y, the region is above the y-axis on the upper side, where the values are positive. Then it tells you that those values are automatically greater than 0. So the inequality becomes y greater than 0. Number 2, is the line continuous or dotted? The line is continuous. So if it is continuous, then we have greater than or equal to. Had it been dotted line, then the equal to will not be there. It will strictly be greater than 0. That is done for line C. And so let's go to line B. Line B, as you can see, it's passing through the point, this point, and this point. The first point is 0, 2. That is 0, 2. And the second point is 4, 0. And 4, 0. With this gradient is given by the change in y over the change in x. So what will it be? 2 less 0 over 0 less 4. That is 2 over negative 4, and the solution is negative a half. We have 2 points on the line, and now the gradient. How do you determine the equation of the line, given 2 points on the line? So once we have the equation, the gradient, what you do is we take at least 1 point. So from the 2 points, I will use any of the points. So let's say 0, 2, and a general point x, y. So with these 2, gradient again, y less 2 over x less 0. And that gradient is already determined as negative a half. Then you cross multiply. So you have 2 into y less 2 into negative 1 x less 0. So this gives you 2y less 4 is negative x, and collecting like terms gives you 2y is equals to negative x plus 4. This is our equation. But we are not told to determine the equation. We are told to determine the inequality. So how do you give the inequality? Now look at these 2. The line B, the shaded part is on this side. This is the shaded part, meaning the values that are on this side are out of the region. They will not define this region correctly. But the values on the other side that is not shaded are the best line to define this region on the line B. So if we test using the point 0, 0, the point 0, 0 is to this side, that is the right side of the inequality. Then we'll substitute it here and say this is 2 into 0, and then this side is 0 plus 4. So you have 2 times 0, which is 0, and then this is 4. So how do you compare 0 and 4? 0 is less than 4. And so we now replace in this inequality and say now we shall have 2y less than negative x plus 4. Then this line is continuous. We said if it is continuous, you have an equal to. So the complete inequality defining B is 2y less than or equal to negative x plus 4. Good. Now, using the same approach, can you be able to determine the inequality of line A? So let's try it again together. For line A is passing through the point 0 and 1. So that is 0, 1. And another point here is negative 2, 0. Negative 2, 0. Gradient will again remain change in y over change in x. And so this will be 1 less 0 over 0 less negative 2. So it is 1 over 2 as the gradient. Pick one of the points and a general point xy. Pick one of the points and a general point xy. So if we do that, we now use the point 0, 1 and xy. So y less 1 over x less 0 is equals to the same gradient determined as a half. And so we cross multiply to have twice into y less 1 equal to 1 into x less 0. So this is 2y less 2 is x. And therefore 2y is equals to x plus 2. Again, we replace in the inequality sign. If we use the same point 0, 0 to test, if I put here 0, I'll have 2 into 0 equal to 0 plus 2. This will be 0 and this will be 2. So again, how do you compare 0 and 2? Definitely 0 is less than 2. So what is the inequality? The inequality becomes 2y less than or equal to x plus 2. And again, it is equal to because the line is continuous. Because the line is continuous. So that is what we need to look at in linear inequalities. That is what we need to look at in linear inequalities, briefly in regards to our lesson today. But we want to look at past questions. We need to look at the past questions that have been in KCSE regarding to the linear inequalities. So as we wait to have the questions now for the past KCSE questions on linear inequalities, I want to look at something. The same on linear inequalities. Same on linear inequalities, that if you are given, you are asked to draw and to shade the region. If you are asked to draw and shade the region, then what you need to do is to look at the inequalities. You need to look at the inequalities. So let's have this as our example. Number 3, you're told to draw the region enclosed by the lines x greater than 0, x greater than 0, and then x, that is y greater than or equal to x, and y greater than or equal to 0. So we need to draw the region that is enclosed by those three. When you draw this, what you need to know is these are general straight lines. We have the line x greater than 0. That is now on the y-axis. And this is 0. This is the x-axis. So the line greater than 0, x. If this side is -1, this is 1, 2, 3. 1, 2, 3. -1, -2, -2. Then the line x greater than 0. This is the y-axis. So the values greater than 0 are on this side. So we shade the opposite side. I will shade on this side. But remember, it is strictly greater than 0. So what it means then, this line ought to be dotted line. This line ought to be a dotted line. The second line with y greater than x. So the line y is equals to x. We all know it is the line through the origin, sloping in this case. But now, because the inequality is greater than or equal to, then this line ought to be a continuous line. So it should be a continuous straight line through the origin. Now, which side is greater? If we test, maybe for example, take this point 2 and 1. This is 2, 1. Where x is 2 and y is 1. And replace it here. Y will be 2, y will be 1, x will be 2. If you compare 1 and 2, 1 is less than 2. So what you need to do is we shall shade this side. We shall shade that side. So we'll have, okay. So we have y greater than or equal to x. And then we go to the other line, which is y greater than 0. That is the x-axis. Now we shade this side. Again, the line has to be continuous. So this is y greater than or equal to 0. So if you look at this shading, there is no defined region. No defined region. So what you need to do is, we go back to the inequality y greater than x and have this as y less than x or equal to x. So if that then becomes now, we shade now the opposite side. So we'll now have this, but now we'll shade this opposite side because it's supposed to be less than or equal to x. And then we add another line, assuming we have x less than 4. Then that means on the x-axis, identify where there is 4 and draw a vertical line through x is equals to 4, again dotted, and the values of x less than 4 will be on this side. So this is x less than 4. So that now we become with a region R. We've only changed this so that we can obtain a defined region based on the inequalities that we have. That x greater than 0, y less than or equal to x greater than or equal to 0, and x less than 4. So those are just simple things that you can try and look at them when you're drawing the inequalities that defines a given region. So let's look at some of the questions that have been tested in this topic from the previous KCC questions. So as you can see on your screen, you are told to solve the inequality. You are told to solve the inequality. And the inequality is 2x less 1 less than or equal to 3x plus 4 less than 7 minus x. Less than 7 minus x. That's the first question that we need to look at. Okay, this is in KCC 2019. So during this, if you are given this kind of a case, as it was tested last year, then we have to obtain a simple inequality from this. And you said we start from the beginning to where the second inequality sign starts from. So you'll have 2x less 1 less than or equal to 3x plus 4. And then again, from the last up to where the second inequality from that side begins, so you have 3x plus 4 less than 7 minus x. Then once you have this, you collect like terms from each. So this becomes our 1, and this is our 2. Solving 1, we have 2x less 1 less than or equal to 3x plus 4. I will collect like terms. This becomes negative x. Take negative 1 to the right side, less than or equal to 5. Something good here, when you divide by negative 1, anytime you divide by a negative or you multiply by negative, the inequality sign changes. So now it becomes x greater than or equal to negative 5. Then we solve for 2. Solving 2. 3x plus 4 less than 7 minus x. Again, collect like terms. Negative x to this side becomes positive. So this is 4x. And this to the right side, negative, less than 3. So over 4, this cancelled. So we have x less than 3 over 4, or x less than 0.75. Those will be the solutions for this. And this was awarded 3 marks. And you can see how easy it is to solve. Let's look at the next question. Next question. In the next question, it's a word equation. And so what we are told is that a school, that is a school, decided to buy at least 32 bags of maize and beans. A school decided to buy at least 32 bags of maize and beans. The number of bags of maize, were to be more than 20. More than 20. And the bags of beans were to be at least 6. The bags of beans were to be at least 6. Then a bag of maize cost 2,500. The bag of beans cost 3,500. And the school had a total of 100,000 to spend. A total of 100,000 to spend. Then you are told we write the inequalities. So how do we work it out? A school is buying 2 products here. We have maize and beans. We are not sure what are the bags of maize that were bought and what were the bags of beans that were bought. So let's have X bags of maize and let's have Y bags of beans. So if we are buying X bags of maize, and in total we need to have at least 32. At least here means 32 or more. And so when you write, it means X plus Y should be greater than or equal to 32. That will be our first inequality, which is now bringing together the number of bags of maize and the number of bags of beans. The number of bags of maize is supposed to be more than 20. So that means x should strictly be greater than 20. And the number of bags of beans should be at least 6. That is now y greater than or equal to 6. But we are told that the price for one bag of maize is 2,500. So the total cost will be, we are buying x bags of maize. That will now give us 2,500x, and y bags of beans, a total of 3,500y, to give us a total of 100,000. So the school cannot spend more than 100,000. So this cost should be less than or equal to 100,000. Then we divide, simplify this, cancel out. Dividing by 5, that gives us 5x plus 7y less than or equal to 200. So these are the four inequalities. The first one, the second one, the third inequality, and the fourth inequality. And that question was 4 marks. So for each of the inequality, you score 1 mark. Next question. The next question, that is in 2014. In 2014, students were asked to solve, the inequality, which is 4x less than or equal to 3x less than 2 less than 9 add x. Then they were to list the integral values of x. So that is for 2014. So let's solve together. We again, just as we dealt with the 2019 case, we extract two inequalities here. So we have 4x less than or equal to 3x less than 2, and solve 3x less than 2, that's less than 2 less than 9 plus x. This becomes our 1, this becomes our 2. So we'll have 4x less or equal to 3x minus 2. We collect like terms. To this side becomes minus. So this x less than or equal to negative 2 as our first solution. For this other one, 3x less 2 less 9 plus x. Take the x to the left side, negative 2 to the right side. So this gives us 2x less than, and then that gives us 11. Therefore, x less than 11 over 2, which is 5.5. So these are two solutions, the first one and the second one. But we need to give what we call integral values. Integral values are supposed to be non-decimal. So in the case we have decimal values, we shall have to round them off. Now, looking at these two cases, x is less than negative 2. X is less than negative 2. And again, x is less than 5.5. X is less than 5.5. I think we have a change in the inequality. This is greater. This sign here is greater or equal to. This should be greater than or equal to, sorry for that. So that we have, this is greater or equal to. So x is greater than or equal to negative 2. And then the other one, x is less than 5.5. So the values of x, the integral values of x now will be, we use the curly bracket. If x is greater than negative 2 or equal to, then negative 2 is one of the solution. Then we go to negative 1, 0, 1, 2, 3, 4, and 5. Because it's supposed to be less than 5.5, and the nearest whole number to 5.5 is 5. So those will become the list of integral values of x. Okay, so those are few questions that we can look at in the previous exams. So let's look at the last one. That is in 2013. 2013, students were asked to give the inequalities, given the inequalities, which is x, given the inequality x less 5, it is less than or equal to 3x less 8, less than 2x minus 3. You have to solve the inequalities, then we represent them on the number line. Again, let's group this to simple inequalities. Start from this up to where the second inequality starts. So we'll have x less 5, less than or equal to 3x less 8. Let me collect like terms. This will be negative 2x less than or equal to this side. This is positive, so that becomes negative 3. Divide by negative 2, divide by negative 2, and anytime divide by negative, the inequality sign changes. So you have x now greater than or equal to 1.5. For the other side, we start from the end all the way to where the second inequality starts. 3x less 8 less than 2x minus 3. 2x to the left side, negative x to the right side. That becomes x less than, that is positive 5. So we are supposed to give the solution or to represent the solution on the number line. So if we draw the number line, we will have 0, negative 1, negative 2. This is 1, 2, 3, 4, and 5. X is negative, is positive 1.5. 1.5 somewhere here, you mark, and because of the equal to, you shed. So we'll shed at this point. Again, x has a solution at 5, so you cycle 5, but we don't shed because it is strictly less than 5. So the values of x greater than 1.5 are to the right. So you draw an arrow facing this side. The value of x less than 5 are to the left side. Again, you draw, so we have intersection of the two. That becomes the representation of the solution on the number line. And that was 3 marks. So we can look at many questions that have been tested in various years from this topic, but because of time, we'll stop there and look at some of the questions that you've asked, for clarification in our lesson today. And so let me start with this one. That is a Form 2 student asking the solution for the solution for 3 plus 2x solution of 3 plus 2x less than negative 3. He gave us, that is the question that we had done before. What you do is, we took this 3 to the right hand side, that is positive. And so we have 2x less than negative 3 plus 3. Negative 3 plus 3 is 0. So that's why we have 2x less than 0, and 2, when we divide both sides by 2, that's why we got x less than 0. Less than or equal to. So there is equal to. So that is the solution that we got, and it was okay. So someone is asking, how can I improve in mathematics? Okay, I will mention something about that. Then this is Region from Kiambu. You are saying, please help me work out this sum. The sum of 3 consecutive odd integers. The sum, yes, of 3 consecutive odd integers is greater than 219. You are told to determine the first 3 integers. So what you do, this student, what you need to do here is to understand what are odd numbers. And so if we start a simple case, the first number being 0, the next is 1, then 2, then 3. The first number is even, this is odd, even, odd. And so you'll find odd numbers, they're numbers whose last digit is either 1, 3, 5, 7, or 9. Those are odd numbers. So the first 3 integers that are odd will be, so we'll let the numbers be x plus 1, x plus 3, and x plus 5. Those are the first 3 odd integers. So the question says, if you add them, x plus 1 plus x plus 3 plus x plus 5, this should be greater than 219. Sum up the x, so you'll have 3x. 1 plus 3 is 4, plus 5 is 9. Greater than 219. Then take 9 to the right side, you have 3x greater than 210. Divide by 3, this cancel out, so x greater than 70. So it means the integers, therefore, the odd integers will be 71, 73, and 75. So those are the numbers that you've been asked to determine from that case. And that's, together with other questions that you've asked, you can also look at more examples from various books as you revise linear inequalities. That is all we can look for in our lesson today. Thank you for being part of the lesson, and have a wonderful day.